What if we're not alone? What if our neighbor Mars holds the secret to extraterrestrial life? An enticing proposition, isn't it? It's this very curiosity that drives our relentless exploration of Mars, seeking clues in its geology and atmosphere that could hint at the possibility of life beyond our blue planet. Mars is more than just a red dot in the night sky. It's a world with its own unique geology and atmospheric conditions, distinct yet somewhat familiar when compared to Earth. Understanding these similarities and differences is crucial in our quest to answer the age-old question, is there life beyond Earth? Over the years, numerous missions have been dispatched to Mars. They've returned with valuable data, painting a picture of a planet that once might have been quite similar to our own. Yet, there is still much to be learned, much to be discovered. To begin our journey, let's take a closer look at the geology of these two planets. Mars and Earth might seem vastly different, but they share some striking similarities in their geology. Both of these celestial bodies are home to towering volcanoes, deep valleys, and vast canyons, etched into their surfaces over billions of years. Now let's take a moment to marvel at the grandeur of Olympus Mons, the largest volcano in our solar system, proudly standing on Mars. This massive shield volcano dwarfs even the mighty Mount Everest, reaching heights of nearly 13.5 miles. That's around 3 times the height of Everest. Its sheer size is a testament to the less intense gravity on Mars, which allows for taller geological structures. Similarly, Mars also boasts the longest canyon system in the solar system, the Valles Marineris. Stretching over 2,500 miles, it's about 10 times the length of the Grand Canyon. It's so long that it could span the United States from coast to coast. On Earth, however, our geological features are constantly changing due to tectonic activity. Our planet's crust is divided into several large pieces, or tectonic plates, that slide around on the semi-fluid layer underneath. This movement results in earthquakes, volcanic eruptions, and the creation of new mountain ranges. Mars, on the other hand, doesn't seem to have active plate tectonics. It's as if the planet's geological clock has stopped. The lack of tectonic activity suggests that Mars is geologically dormant, but we're still learning about the mysteries hidden beneath its surface. In essence, the geology of Mars and Earth is both similar and contrasting. They share some common features like volcanoes, valleys, and canyons, but the way these features evolve over time is vastly different due to the presence or absence of tectonic activity. While the geological features might hint at similarities, the atmospheres of these two planets tell a different story. But that's a tale for another time. Stay tuned as we delve deeper into the fascinating worlds of Mars and Earth. An atmosphere isn't just air. It's a shield, a blanket, and a communicator, all in one. It protects us from cosmic radiation, keeps our planet warm, and enables the transmission of sound waves. So let's dive into the atmospheres of Earth and Mars, comparing and contrasting their compositions and their implications for life. The Earth's atmosphere is a cocktail of nitrogen, oxygen, argon, and traces of other gases. Nitrogen, the most plentiful, makes up about 78% of the atmosphere, while oxygen, essential for life as we know it, constitutes about 21%. Our atmosphere is relatively thick, providing a strong shield against harmful solar radiation and space debris, and it also creates a greenhouse effect, trapping heat and making our planet hospitable. Mars, on the other hand, has a thin atmosphere, dominated primarily by carbon dioxide, which accounts for about 95% of its atmospheric composition. Nitrogen and argon are also present, but in much smaller quantities. The thin Martian atmosphere doesn't provide much protection against solar radiation, and it's not efficient at trapping heat, hence the frigid temperatures that can plummet to -80 degrees Celsius at night. One might wonder, why is Mars's atmosphere so thin? Well, it's believed that Mars lost most of its original atmosphere billions of years ago, possibly due to its weak magnetic field. The solar wind, a stream of charged particles from the sun, likely stripped away the Martian atmosphere over time. The differences in the atmospheres of Earth and Mars have significant implications for the possibility of life. Earth's nitrogen-oxygen-rich atmosphere is necessary for most known forms of life. Mars' thin carbon dioxide-dominated atmosphere, meanwhile, doesn't support life as we know it. However, it's worth noting that extremophiles, organisms that thrive in extreme conditions on Earth, might find the harsh Martian atmosphere to their liking. So, with all these differences and similarities, what does this mean for the possibility of life on Mars? Could Mars be our next home, or is it a barren, inhospitable world? That's the question that has been dancing in the minds of scientists and space enthusiasts alike. We've spent the last few scenes comparing and contrasting the geological and atmospheric features of Earth and Mars, and now it's time to bring it all together. Let's start with the geology. Mars, like Earth, has a diverse landscape with mountains, valleys, and plains. The highest mountain in the solar system, Olympus Mons, calls Mars home. But unlike Earth, Mars doesn't have tectonic plates. This means that when a volcano forms, it just keeps growing and growing, leading to the formation of such gigantic mountains. On the other hand, Mars's atmosphere is a stark contrast to Earth's. It's thin and composed mostly of carbon dioxide, with traces of nitrogen and argon. This thin atmosphere means that Mars is much colder than Earth, with temperature swings that would make even the most hardened Eskimo shiver. So, what do these characteristics mean for life on Mars and potential human exploration? Well, the conditions are harsh, to say the least. The thin atmosphere offers little protection from solar radiation, and the cold, desert-like conditions would be challenging for any form of life as we know it. However, it's not all doom and gloom. The geological similarities suggest that Mars once had a climate more similar to Earth's. The presence of ancient riverbeds and lake deposits hints at a past where liquid water flowed, and where there's water, there's the potential for life. For human exploration, Mars presents both challenges and opportunities. The harsh conditions mean that any manned mission would require extensive preparation and resources. But the prospect of exploring a new world, of standing on the peak of Olympus Mons and looking out over an alien landscape, is a tantalizing prospect that continues to draw us in. The quest for life beyond Earth continues, and Mars, with all its mysteries and similarities to our own planet, remains a fascinating frontier. Mars and Earth, two planets in the same solar system, yet worlds apart. As we've journeyed through this cosmic comparison, we've discovered the striking similarities and stark differences between our home planet and our intriguing neighbor Mars. From their geological features to atmospheric conditions, these two celestial bodies have offered us a fascinating study in contrasts. We've learned how Mars's towering volcanoes, deep canyons, and thin carbon dioxide-rich atmosphere compare and contrast with Earth's diverse landscapes and life-sustaining atmosphere. And yet, despite the inhospitable conditions on Mars, we've seen how the red planet holds tantalizing clues to the possibility of past, and perhaps even present microbial life. Our ongoing and future explorations of Mars, driven by curiosity and the quest for knowledge, are paramount in our search for extraterrestrial life. As we continue to explore the cosmos, we inch closer to answering that age-old question: are we alone in the universe?